Okay, so the situation is this. How do you determine what sample size to use for a certain level of confidence that you want? Well, here's a situation that we can apply this to. It says, the college president asks the statistics teacher to estimate the average age of the students at their college. How large a sample is necessary? Well, the statistics teacher would like to be 99% confident, so we're going to write that down. Confidence level is 99% confident that the estimate should be accurate within 1 year. When it tells you its level of accuracy, and it says within 1 year, that's the value of E, your error of the estimate. From a previous study, the standard deviation of the ages is known to be 3 years. Anytime it's from a previous study, it's the population standard deviation they're giving you, and that's 3 years. So from the word problem, that's all the information that we have. We can find the z sub alpha over 2 from the level of confidence that we want. If you've got this memorized, you know it's 2.58 for 99%. The formula that we'll be using today is n equals the fraction of z sub alpha over 2 times the standard deviation divided by the error of the estimate. Now this fraction needs to be squared. So if we plug this in, we're looking at a z sub alpha over 2 of 2.58 times a standard deviation of 3 divided by an error of the estimate of 1, and that's squared. So typing this into your calculator, you have 2.58 times 3 divided by 1, and that's going to be raised to the second, or squared. And this means your n is approximately equal to 59.9076. We know that the larger your sample size, the better it will represent your population. And the better it will represent your population means you have a better estimate for your population. So, why don't you always round up? That's what we're going to do. We're always going to round up. For any decimal associated with your sample size, you're going to round it up. Don't round to the nearest. Always round up. Because you're doing yourself a favor by making the sample size larger. You're making it be a better estimate. So this sample size is going to be approximately 60. Even if this was a 0.1 and not a 0.9, I would still round this up. And I need to make that clear to everyone in this room. We always round up when calculating our sample size.